why don't we start with who are you two and what's your background and why are you guys AI experts?
My name is Dan. I'm a VP of AI at Data Monsters. My personal background is that I'm 2 decades in data analytics and data science. I managed projects for big companies and for startups like a GE, AB InBev, Boston Scientific. My role here is to be on the front line, to understand needs, customer needs, and to bring the right people, AI people, to the projects and make them successful. That's pretty much all. It's pretty simple, German.
Yeah, my name is German. I'm an industrial AI solution architect. My job is to understand the business needs, the challenge that the business has, the business process or manufacturing process has, and build a solution and then deliver this solution to the customer. Basically, my job is to make it work at the factory floor. Yeah, I also worked with a couple of customers that Dan named, both with the bigger ones and the startups.
Okay. And what's your scientific or mathematical background in AI?
My first profession was aircraft engineer, helicopter engineer, but I did programming from my childhood, as I remember myself. I was always interested in computers and programming. And I did a PhD thesis back in 2005, and it was connected to industrial automation and data science. But there was no such term as data science back then. We just referred to big data and data mining.
Mm-hmm.
So looking for patterns and using large amounts of data to mine some insights both for industrial and supply chain use.
Okay. So why do you think it's relevant now? Why is data science and then by extension machine learning and AI relevant now? We always had models and ways to optimize or solve things before, but what's the gap?
At this present moment, a lot of stuff is mature enough so that we are able to make practical applications of these principles. Most of them were there for years. There is not much new stuff happening. There is a lot of new stuff happening, but the basis for that is actually it was there for quite a while. We've got really good computational power now, so we're able to do mass calculations using GPUs, hardware that wasn't available in that scale earlier. And also the market is getting more mature. A lot of people started talking about AI with introduction of large language models, namely ChatGPT, right? It wasn't the first large language models. It was just one of the most spoken about. It inspired a lot of discussion also in manufacturing space, and people start to look more into AI as a solution for some of the problems that were harder to solve with traditional ways of programming.
So here's a very important question. How tired of ChatGPT are you? Do you think it's still a relevant thing to talk about, or do you roll your eyes?
I love it. I use it. It's a great tool. And I would say ChatGPT is just one of the great displays for people to use. The displays of power that AI can bring to people. And it's a great tool, and again, I use it daily for different stuff. And we also use LLMs for some applications that are not chat related. It's a great tool for automation of processes.
Cool. So we had a question from LinkedIn that was okay, if we're talking to AI experts that are thinking about industrial automation or manufacturing, what are some examples of how we would apply it there?
So there are a huge amount of cases, and as the German already mentioned, many of them they existed for decades. We can take prescriptive maintenance or predictive maintenance if you wish. So the concept is there, I don't know, maybe 5 decades or so. So still, what's new? The new is that we can use some critical algorithms. We can collect much more data from sensors. There are a lot of cheap sensors now, right? So you can collect multiple data streams. You can do it in real time. You can process all these data streams in real time now, and you can get those alerts and those predictions much earlier, much more in a more robust way, right? So algorithms are changing, computational power is changing. So we get better results, much more accurate, faster. For some use cases, that becomes pretty much something that makes them alive, actually. For some use cases, you're not going to do them because it's too expensive, right? Or you're too late with your predictions. But when you can do it fast, when you can do it accurate, you can come up with a broad range of use cases. So besides maintenance, and even within maintenance, you can go now deeper with large language models because you can go and find relevant documentation or solutions for specific problems that arise during your maintenance process, right? And you may want to find a specific list of actions you want to do in specific situations to solve the problem. And sometimes that can be a pain because the knowledge base is huge and you spend a lot of time just searching and reading instead of solving the problem itself. Large language models can be really, really valuable here because you just can go ask and get like a very straightforward list of action that you should do, right? This is around maintenance. Then you can go into quality inspections, and this is a huge space also. So obviously that's not something new. So everybody did that for a while, right? Now you can use cheap cameras with nice resolution, with nice frame rate, so you can process all these data flows using very powerful edge devices based on, for example, on NVIDIA Jetson devices. And you can do predictions, or you can identify anomalies or like scratches, any kinds of issues with your product producing defective items.
So let's say that like it's a manufacturing line. Like where would someone do this? Like is it electronics, food and bev? I know it could be anywhere, but let's go through like a real case.
Let's take food and beverage. You have all the way like production lines, like packaging, all types of packaging, right? Obviously, on our experience, you can have anything between 1% to 5% of defects on those lines. Sometimes that's okay to have something defective. Sometimes that's not okay, and you would like to stop that. So we can talk about, for example, beer packaging line. Typically, what you see, you may have scratches, dents on those cans, and you don't want to show them on retail store, right? So you want to escape the situation, stop that before you package those on pallets and send them to retail. But that's a pain because the speed of those packaging lines is amazing. Like thousands and thousands cans are passing by, and you need some very powerful technologies to identify those scratches in real time. And those defects are always different. So they may arise in different parts of the can. Light can be different. The print can be different. Like the can itself can be different. Then you have drops there, like moisture and all
right.
these,
and
like
traditional vision, it doesn't work, right? Sorry. Like it does.
Yeah, so
traditional vision doesn't work well with like any type of variation, right?
Yeah. So you can just check a few cans per hour, I would say, right? A person may come and just grab a couple of cans and check them manually, but that's the percentage. You can just statistically, it's nothing, right? So you understand that you may catch some kind of really massive defect this way, but to the moment when you identify that, you have thousands and thousands of cans you have to get away. But with current technology, that's totally different. So you can identify this problem in a minute. So this is the serial defect. And so some huge defects you can identify even faster. So, and you just stop it without anybody on the line. You need just a camera, these nice GPU powered device there, special model that will process all this stuff, and that's it. So it can work 24/7, catching those defects, alerting somebody, and that's a very nice line without any human being there. And still with quality control, that's much more powerful. And here is what we get. So we get the superhuman performance, right? So this is the case where AI can give you a much better value than a human can do. Yeah, Jamal, maybe you would add some more use cases on top of that.
Yeah, basically, people can do a lot of stuff at the manufacturing floor, but there are two challenges connected to human operations. First is people are not as fast as you may need sometimes in manufacturing conditions, and also people get tired and they miss some of the problems that should be identified. But at the same time, people are way more universal than machines at this moment. So the first stage of automation is traditional automation, which is mostly rules-based and requires customization and engineering for exact case and exact product. What AI brings, especially in computer vision field, is more universal approach to products and processes. So it involves less engineering and customization for the exact case. It's more universal. That's
Gotcha.
probably the biggest difference.
So if you were to like come up with like a grand vision of AI working at its finest, like your factory of the future, like what do you think that would look like?
I don't know if we are close to full automation of a factory. You can provide high level of automation now when your product is more or less standard and does not change a lot. But we see that modern manufacturing site is usually pretty dynamic. Products and processes change a lot. So the future AI-powered factory would be the one that is able to react to those changes in production schedule, in the products, in processes, and adapt to that and choose the optimized path with high throughput and without a lot of people involved.
Yeah. That's actually interesting, like that your viewpoint of automation, fully automated, is very different than what I think of as a controls engineer, right? Like we have even semi-automation or even a small amount of automation where people are doing most of sorting or whatever, and there's an assist with the machine. And there's scales of that, but like when you're saying fully automated, it's more like it's not just the actuators and robotics, it's like the ability to adapt to what's happening to the environment or the manufacturing process itself.
Yes, absolutely. It's decision making in changing environment.
Right.
Changing environment is the key here. Variability is one of the key factors when you consider automation, and that's where AI helps.
Right. Yeah, for sure. I mean, like just as a, I do a lot of motion control, and if you have a new package or format of a bottle, you have to go in and change all of those things. Or, if it's a process control, the humidity changes, then, if it can just completely mess everything up. And, we can model that to a certain extent with mathematics, but really like what AI is doing the reverse. It's figuring out what is happening for you. So
basing on data, right? So
yeah, exactly.
That's data is king. And one of the factors of development of AI in manufacturing is we get more and more data, more cameras, more sensors. AI basically is, or machine learning as a part of AI, is basically programming with data. And
right.
Here, we can also model data. We can create synthetic data, which we use quite a lot in our practice. So creating 3D scenes using, for example, NVIDIA Omniverse and USD, Universal Scene Description.
So just to stop you there, like if someone's not familiar, what does synthetic data mean?
Yeah, it's creating your simulation of your process and rendering images for computer vision training, computer vision model training, instead of...
Or even a physical model too, is right? Like if you had the dynamics or thermodynamics physics of it, you could feed it into it as well.
Yes, absolutely. It's just my area of expertise in more in
computer
vision. That's why
I can cheat and know that you know that
basically
as well.
It's
but yes,
any kind of simulation that creates data that you use for model training.
Right. And then why it's relevant in controls engineering is like a lot of people are talking about digital twins, right? Is that like you have some basis for knowing how it should work, and that gives you some current constraints as to what is realistic in the real world.
Right. First for display of how the system works, and then to predict and maybe to control the physical system.